let's see. You observe how that how is the machine able to know whether it should come down, when it should come down? Yes. How is it able to know? You have it right there. What do you have it? Sensor. You see that sensor? As the last part comes in and the sensor detects it, there is your sixth part, right? It's able to do six. You have six nozzles, so six bottles can be filled. So that sensor, the last sensor, is what will give the confirmation that the sixth part, the sixth bottle has come in, so this can come down, right? The PLC will give the instructions. You observe the sensor. Right, that and you see we had that category in part fading devices, selector, right? That's basically a selector. Okay, that belt, when it is moving around that loop, it will take these caps, right? Selector, out of these all parts, cap elevator for feeding caps to capping machine. You see, that was your rejection based on machine vision. Right? Any doubts in that video? No doubts, right? That was your example of intermittent transfer system, right? Okay, continuous we saw in that bottle capping, I mean that beverage filling, and intermittent asynchronous we'll see. Okay, so when it comes to transfer mechanisms, you have these various types of transfer mechanisms. What is their purpose? As the name suggests, to move it, right? Transfer it, move parts between the stations. So basically, two categories we can make, either linear transfer or rotary transfer. Okay, linear transfer, you have linear travel for these inline machines, and rotary for rotary motion, or dial indexing machines, right? Because the rotary table will have to have that dial indexing done. We'll see how is it done. So when it comes to linear transfer system, linear transfer mechanisms, you have walking beam system. That's one of the important topic. Okay, that walking beam system in linear transfer. Work parts are lifted up from the workstation. You see, if you look at the diagram first, yes, this is your six station walking beam, including two vibration stations. So it's a six station one. Okay, basically 1 2 3 4 5, right? Six stations is what you have. So what it will have is, if you observe, you see, it has this, one is a fixed station, another is a transfer, sorry, fixed beam and transfer beam. Okay, these two beams will be used to transfer these work parts. Okay, the fixed station beam will be fixed at one place, and the walking beam and the transfer beam will take the work parts. Okay, and it will shift them. You have what is called nests here, basically grooves. Okay, which will be used to lift the work parts and place it again. So the grooves are both in the transfer beam and the fixed station beam. Okay, and also in the work parts, so that it can be so that the transfer beam can lift the work parts and move it forward. So what it does is, basically it will lift the work parts. I'll show you what is happening here. It will lift it like this. Okay, in one operation. In the other operation, it will move in this direction. Okay, and then it will come down. So basically you have moved this distance, right? Lift it, move, and place it down. So that's what is happening here. You see, motion of transfer beam, lift it up, move it to the right, take it down. So this transfer beam is what is moving and transferring these work parts. So one after the other, you have this, we'll see a video that will clarify. So this is a, what you call a visual diagram you can draw in the exam if it comes up, and for you to understand, right? So work parts are lifted up from the workstation location by a transfer bar. That's what we calling, right? That moving beam transfer bar, and moved one position ahead to the next station. So that once that movement of the to the right is basically one, what do you call, one position movement, right? The transfer bar then lowers the pans on into nests, which positions them more accurately for processing, right? Lifts it up, and nests, right? I told you that basically those grooves are what is nests. For speed and accuracy, the motion of the beam is most often generated by a rotating camshaft powered by an electric motor, or a roller movement in a profile powered by hydraulic cylinder. So that motion, the mechanism, it is generated by a rotating camshaft. So powered by an electric motor, or a roller movement in a profile powered by hydraulic cylinder. So you see, we have seen the two, right? Then we will see that video. Okay, that will clarify, because the reason why I'm showing you videos is, videos are more powerful, right? We all can agree that to understand, if you see a video and then you understand, you read the matter, it becomes very easy, right? Isn't it?
Yes, sir.
Yes. So you see this example of a walking beam transfer system. You see how they are moved? This is exactly what I was trying to show you. Okay, this 3-4 seconds will clarify the matter. How they are moving ahead. Okay, because of that bottom bar, or whatever you call it, movable beam, taking these work parts up and then moving it. Observe carefully. So each station is responsible for that either filling of. I believe this is for filling of some small, what do you call, caps. So this is when it is not operating. Okay, these are all what do you call, workheads. For a dedicated function they are there, but just so we can see it, they have lifted it up. Okay, so it is not like they are moving just like that. We have made it, these workheads, to move up so that we can see what is happening. Okay. Okay, this is without the work parts also, another clarification to make. So this is a very good example to show a linear transfer mechanism, right? One example is your linear walking beam system. Okay, if you want to have a linear transfer of work parts, walking beam system is one method to or one technique to do it. Okay, I hope this video is clear, or if there are any doubts, you can ask. No. Okay, so that is the walking beam system. If you want to do it, draw it pictorially, then this is what it looks like. Okay, this is how you can show the motion of it. And there is some confusion here. I have observed that the fixed beam you see in the first diagram, the yellow one is referred to as a fixed station beam, and this sky blue is, or whatever you call it. Okay, yeah, sky blue is a transfer beam. In the next one, that is your transfer beam, this is your fixed station beam. So there's a confusion here, but that video I hope will clarify. Okay, you designate only one as your fixed and other as the transfer beam in all the diagrams, all the steps that you're showing. Okay, so just wanted to clarify. Other thing is your powered roller conveyor, we saw, right? Roller conveyor system. And I hope I've, yes, I've kept a, yes, you see, this is generally in your what do you call mm, this what is it called, pipes. Okay, for long pipes you'll use this kind of system, roller conveyor system. Okay, and even this, I believe, yes, tires, you see, another example. So when there are hefty things involved, bulky systems, bulky work parts, then you'll use this kind of roller conveyor system to transfer work parts. They're used in general stock handling systems as well as in automated flow lines. Conveyor can be used to move pans or pallets possessing flat riding surfaces. So flat riding surfaces is what is required, because only the flat surfaces will be able to move it, right? If it is irregular, then it will become very difficult. So that's another thing. Rollers can be powered by either of two mechanisms. So the two mechanisms could be either is a belt drive, right, in which a floating moving belt beneath the rollers provides the rotation of the roller. So in beneath these rollers, you could have a flat belt. Okay, and because of the friction between the belt and the rollers, right, as the belt moves, because of the friction, the rollers also move, right? So these rollers will rotate, so rotation of this will cause the work part to move, right? Very, very simple. Another thing could be chain drive. Chain drive is the second common mechanism used to power the rollers. Powered roller conveyors are versatile transfer systems because they can be used to divert work pallets into workstations or alternate tracks. So that was your roller powered roller conveyors. Okay, so it's already 2 p.m. No doubts so far in today's class or powered roller conveyors. Okay, then we'll end the meeting. Thank you.